Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we cover all things Gen Chem related. In this video, I'll be talking about trends that exist on the periodic table related to atomic radii. Let's get started. So if we think about what the atomic radius is basically the distance between the centers of atoms if we align them together. So you can see in this example of krypton, it's the distance from the center of one atom to the next. And so that distance is going to vary based off of the size of the atom that we're dealing with. And there's trends that we can use to help us to predict whether or not an atom we would expect to be bigger or smaller compared to another atom based on where it's located. And so the general trend as we go down the periodic table, if we have our periodic table here, is that as you go down the periodic table, because the size of those atoms is getting bigger and bigger and bigger, the distance between them is going to get bigger and bigger and bigger as well. And so we would say that for the atomic radius, you would expect an increase going down the periodic table. Now, in regards to what's happening across the periodic table, as we put more electrons into a valence shell, we're creating more opportunity for those electrons to be pulled in tighter to our nucleus that's found where those protons are. And so you're actually going to end up getting a decrease as you go across the periodic table, or what I really like to show it going this way, showing the arrow as increasing, meaning at the top of your table, at the beginning of your row, you would have larger atomic radiuses that exist, versus as we add in more electrons in that same valence shell, you get that tighter, more compact situation that occurs. And this is related to the effective nuclear charge that's increasing across that valence shell. And so this is the trend that we're really going to want to remember, is that it's going to increase going to the left of the periodic table and decrease as you go down the periodic table. Now, there are exact values out there that do exist. However, you should not be responsible for actually memorizing any of these, but more so just being able to look at the position of an atom and be able to predict what that relative atomic radius would be based off of where it's located. And so you can see that there's this reset that happens as you go down the groups, where you see that your group 1, your lithium, sodium, potassium, all have the greatest atomic radii. And then as you go to your noble gases or electrons in that valence shell, you're decreasing that size. Okay, and so how we're going to put this into practice is that you would literally be most likely given some atoms that you have to figure out, well, who's the bigger one or who's the smaller one, or put things in order. And so you just want to think about where they're located on the periodic chart and come up with a decision. And so again, just to remind you, for your atomic radius, the trend is that we're increasing down the periodic table and increasing towards the left. Okay. And so if we were looking at between like nitrogen and fluorine, well, we would say that nitrogen is found further left on the periodic table. So we would expect it to be bigger. If we were comparing carbon and germanium, you can see GE is further down. And so we would say that would be the bigger of the two. And if we're dealing with aluminum and nitrogen, well, now in this case, we would be able to say that aluminum is the bigger one because it's further down and further to the left. But when we're looking at aluminum and germanium, that's a little bit more difficult because one is further to the left, one is further down. And so we couldn't make a declaration just based off of just the trend information as shown here. So we would just say we can't declare it, not applicable here. You would need a little bit more information. Okay. All right, so let's put that into practice. So if we look at carbon versus oxygen, who would be the larger of the two? Well, we would select carbon because it is further to the left. Okay, good. If we were doing lithium versus potassium, well, potassium is further down, and so we would select potassium as your answer. Okay. If we look at carbon versus aluminum, well, aluminum is further down and further to the left, and so we would say aluminum. And then last but not least, selenium or iodine. Well, those two would have opposing trends because one is further down, one is further to the left. Now, when we look at the trends that exist for the atomic radiuses of transition metals, it's still basically the same thing, but just a smaller difference between the different atoms that are present. You're still going to have that increase as you go down the groups, but that size difference that happens is a little bit less pronounced within those that are in that D shell. And this is mainly because the effective nuclear charge within that S or sublevel is approximately the same. Okay. So I hope this video helped you understand the trends that exist for atomic radius. Make sure you guys like, comment, and subscribe, and let me know what other videos you would like to see. We'll be back with more videos. Have a great day. Talk to you guys soon. Bye-bye.